Hello. In this video, we will solve a calculation based on steam power plants in thermodynamics. Let's look at the question. In a power-generating steam plant, the boiler operates at a pressure of 8 megapascals, while the condenser operates at a pressure of 4 kilopascals. The power output of the plant is 10 megawatts. The question is to calculate the heat transfer per unit mass in the boiler and the condenser, the specific work output of the turbine, the cycle efficiency, and the mass flow rate of the steam. Let's look at the solution. We will assign the following numbers to represent the different stages of the process. After condenser, we can name it as stage 1. Stage 2 is after pump, stage 3 is after boiler, and stage 4 is after expansion in the turbine. We use the steam table to do this calculation. The first objective is to find the enthalpy at every point of this cycle. We look at the saturated water and steam table at 8 megapascal. We use saturated water and steam table as in the question it is not mentioned that the steam is superheated. 1 bar is equal to 100,000 pascals, so 8 megapascal is 80 bar. As shown in the video, we can get the enthalpy and entropy values at this pressure from the steam table. Now we look for the enthalpy and entropy values at pressure 4 kilopascal, which is equivalent to 0.04 bar. Using values obtained from the steam table, we can calculate the dryness fraction of the steam before it enters the condenser as shown. We are calculating the dryness fraction of steam after expansion in the turbine. We do that as we use this to calculate the enthalpy at stage 4. Our next objective is to find the enthalpy at each point. The enthalpy at point 1 is the same as the HF value for the condenser pressure, and that is 121 kilojoules per kilogram. That is because unless anything specifically is mentioned in the question, we assume after the condenser the fluid is in liquid state. To find the enthalpy at point 4, we use the formula as shown. We use dryness fraction, which we calculated before, and substituted that into the equation to get enthalpy at stage 4. At this stage, after expansion, the gas is a mixture of vapor and liquid. Hence, we use this equation. We know the work done by the pump is equal to H2 minus H1, which is the change in the enthalpy after and before the pump. The equation for the work done is the change in pressure times the specific volume. So we can find the specific volume from the steam table, and the value is 0.001 meter cubed per kilogram. Substituting these values in the equation shown and rearranging, we will get H2 is equal to 129 kilojoules per kilogram. And H3 will be equal to Hg, that's 2758 kilojoules per kilogram. As we assume after boiler, it is a dry vapor. Once we have found the enthalpy at each point, the calculations become much simpler. To find the heat for the boiler, we find the difference between H3 and H2. The heat transfer per unit mass in boiler is 29 kilojoules per kilogram. Similarly, the heat transfer for condenser is equal to H4 minus H1, and it is 1/16 or 8.21 kilojoules per kilogram. The turbine specific work output is H3 minus H1, and that is 1028.79 kilojoules per kilogram. The cycle efficiency is the net work divided by the heat input. Cycle efficiency is calculated as 0.388, and that is 38.8%. Now to find the mass flow rate, we divide the power with the net work, and the mass flow rate is 9.796 kilograms per second. Thank you for watching the video. If this video has helped you, consider liking and subscribing.